Alright, nuclear. We're finally here. There's a lot of college professors who will start off with this chapter because it really. And by the way, I'm going to do a little review here. It's going to be a little bit of atomic theory review because of that. There's a lot of people who will start off with this chapter in college, and then there are those who will skip it completely. It's funny. It's one of those weird things. But I like to save it for last. But it does require to do a little bit of a review. You see, the logic behind starting it in the beginning of the year is because that's when we first start talking about protons, neutrons, and electrons. And we are talking about atomic changes when we're talking about nuclear chemistry, okay? So I'm going to do a little bit of you're going to have to know all the notations you knew back then and what the atomic mass, atomic number, mass number, all those things mean again. So I'm going to do a very quick, kind of summarize what we probably did in a couple of days into like one board here. And then a couple of examples on a second board. And then I'm going to give you a sheet to practice it one more time. It's the same basic sheet you saw before, but you'll have the rest of this period to do them, just filling in number of protons, neutrons, electrons. And this is actually very important because you can't do the calculations without knowing these. And it's been a while, so I thought I'd do them again. So it requires a little extra review here, one period basically of review. But it's worth it because you're going to use this the whole chapter. Let me just very quickly go through the particles. The electron, you should remember, has negative charge, and it's located outside the nucleus. We're not going to be dealing with electrons, at least not ones that are outside the nucleus, a whole lot in this chapter, because this chapter is all about the nucleus, hence the term nuclear chemistry. Electrons aren't in the nucleus. What are we going to be talking about? Stuff that we didn't talk a whole lot about throughout the rest of the year. Hopefully you remember this. But chemistry, almost all of chemistry has to do with electrons. That's why the periodic table, all right, we've been looking up there so many times. Oh, you're going to gain 2 or lose 1. What group is he in? You could predict his charges, and then write compounds, then write formulas, then write all that stuff had to do with electrons being transferred or shared. Okay? Well, we're not going to deal a whole lot with them. We're going to deal a heck of a lot with. Oh, by the way, before I get to that, what's an ion? One more thing. An ion? Yeah, he's an electron. He's an atom that's lost or gained electrons. He's got a charge. Okay? But we're going to be dealing with not electrons and ions as much as we're going to be dealing with protons and neutron changes. See, when you're talking about the chemical reactions we've been talking about for the past 7 months or more, they did not involve one time for any equation the number of protons changing or the number of neutrons changing. You assumed the number of protons in your sodium was exactly the same before and after both sides of that equation. Sodium chloride, sodium ion, sodium metal. They all had 11 protons, all right, and all had the same atomic mass. They didn't change. They had more neutrons. We didn't care if they did, all right. Protons, obviously positively charged, and they're located in the nucleus. What do we call, here's the first term we got to remember, what do we call the number of protons? What's another name for the number of protons? The atomic number. Okay, not the atomic mass, not the mass number. We're going to go over those also as review. Remember, we're only doing this one board as review and then some examples. And you'll have the rest of this period to do this sheet, which is going to be practice, because you're going to be writing these in every single nuclear equation we do. You're going to be writing these again, and it's been a while. We haven't had to write them the way you're about to write them for a while.
Nuclear the rest of the year.
No, we still have one more topic after this.
What is it?
Redox. That doesn't mean much to you, but redox chapter. Not detox. Redox. All right. So that's protons. Number of protons is the atomic number, and then we have neutrons, which are of course neutral. They have no charge. They're located also in a nucleus. They're very similar in mass. You're going to see why they're so similar in mass very soon, by next week, when we start writing equations for these guys. And do you remember what neutrons control? What would they change about something?
The government.
The government, yes. They're radicals. Isotope, yeah, they're going to be isotopes. they're going to change. Number of neutrons changes, you have a different isotope. And therefore, your mass number will be different also. Another name, by the way, for an isotope, a more generic name would be a nuclide. It's more generic because isotope generally means guys of the same element type with different numbers of neutrons. Nuclide is just anybody on a periodic table who has a specific number of protons and neutrons. It's called a nuclide. And finally, the last thing you have to know to be able to do some of these calculations is what's called the mass number. And you should remember that the mass number is the number of protons plus the number of neutrons. I hope you remember that. And again, this is another great example of why, although this final will technically not be cumulative, this is another great example of why it is. For all intents and purposes, this final is cumulative. Okay? We covered this back in chapter. I got a worksheet out here for today, so I had to go and look for it. This is chapter 3. Okay? All that stuff from chapter 3 you're going to be using to do nuclear. You can't get away from it. So you had it. I taught it to you back then. If I didn't cover nuclear now, you'd never see it again. But this is going to be virtually a comprehensive final, even though we split it up into a midterm and a final this year. All right. Okay, here we got that. I'm just going to do some examples of the kind of problems you have to be able to do with these. We'll do this chart right here and fill it in. Okay. You can just do it as we, make the titles. That's all you really have to make. And then we'll just fill them in as we go along. You don't have to put box or anything around them. Just make the titles of the chart. I'm not going to, remember, this was probably about 2 days of notes here, summarized into 2 boards, all right, when we first taught it. So obviously I'm not doing this to the same extent we did it back in the beginning of the year, but I don't think I have to because it's going to all come back to you. I'm not writing down examples of nuclear notation or hyphen notation because as I do these, by the time I get done with the 5 examples that are up here, no one's going to say, oh, I don't understand this, because you all had it back then anyway. So let's just do one at a time. And by the way, this is exactly what your homework. It's not really homework, it's going to be classwork because you're going to do it in this first period. The second period we'll be doing something new. At the end of this first period, I will, as you hand these in, sign your papers and talk to you a little bit more maybe about. Some people were absent last week, and we talked a little bit about what to sign up for next year. So I will talk to you a little bit about that too, but we'll have time. Okay, you ready? All right, now if I tell you you have 12 protons, what other row, whatever column I should say, is going to be also 12? Electrons. Why electrons are going to be 12? Yeah, we're talking about a neutral atom here, so you're going to have the same number of protons as electrons. All right. How am I going to get the mass number? What is the mass number again? Remember? Protons plus neutrons. So it's going to be what? 26, right? Now, here's the part you probably don't remember. The 2 different kinds of notations. By the way, they have different names. I call this the nuclear notation. This is the hyphen notation. The hyphen notation is a little bit easier. You simply need the symbol of the element followed by the mass number. Well, how are you supposed to know what element you're talking about? That guy right there. The atomic number, or the number of protons, tells you what element it is. What element is this? That means I just put Mg, and I follow that by his mass number of 26. Okay? Now the nuclear notation was a little different. You remember this? You write the symbol, and then as a superscript, you write 26. That's the mass number. And the atomic number below that. So that's the 2 notations. By the way, I didn't have room for it on this chart up here, but I could just as easily have written another column called atomic number. The column that was atomic number, what would that be identical to? Yeah, this guy right here. have to be the same, right? Okay, let's try this next one. And this time I'm told I have 4 electrons and the mass number is 9. If I have 4 electrons, what else has to be 4? Protons, which, by the way, that's also the atomic number. If I know this time the mass number is 9 and I've got 4 protons, how many neutrons must I have? 5. How do I know what element I'm talking about here? Which number am I going to use? 4, 5, or 9? It's going to tell me the element's name. 4, because that's how many protons he has. And the guy who has 4 is beryllium. So Be9. Or, how would you write it here? 9/4. And it's not, there's no divided by there, guys. You don't put, it's not a fraction, 9/4. It's 9/4, but there's no fraction there. Now here I just give you sulfur 33. I know what's going to happen. People will put 33 protons and 33 electrons. Is that correct? No. That's his mass number is 33. Okay? I have to look at my periodic table, which, by the way, I know you're used to looking up there, and I don't blame you. That's why it's there. All the common elements are up there, the top half of the periodic table. However, we're dealing with nuclear now. I'm telling you right now, most of the elements you're going to deal with, especially coming up later this week and next week, are going to be down here, the bottom of the periodic table. Okay? So you're going to have to get used to using your own periodic table. You're not going to find all the elements that you need up there. Anyway, I look up sulfur. There he is. He's got 16 protons, so I put a 16. Oops. I put a 16 for here and a 16 electrons if he's neutral. How many neutrons does he have? 17. Right? And his notation for nuclear notation would be S3316. Right? Fill this next one in on your own. Matter of fact, fill the last 2 in on your own, and I will go over them. You should know by now how to do these.
Can water go bad?
Not water itself, but stuff that's in it. You've had an old water sitting around now. Is that like,
I was in my car for like 2 weeks.
that would be bad.
I figured it'd be okay, but...
Yeah. I mean, if it was never opened, it should be.
Oh, it was. Okay.
Then you would definitely not want to drink it. Because you got bacteria and stuff in there growing. Yeah. Okay, 14/9. What is, who's 9? Fluorine? Yep, F. So F14. And by the way, on the paper I'm giving you, you could either do the whole word, sulfur 33, or F4. You can do just a symbol. It doesn't matter. This guy here, Ne22, 10 and 10, 22 and 12. Y'all get that? All right. Good enough. That's what your homework's going to be, classwork's going to be.